Everyone, you're welcome back to Mega-Hedge Chemistry Forum. My name is Akan Kubiatelekanga. I want to say a very big thank you for all our subscribers. Those of you who have always find it interesting to subscribe, to follow up on us, we say a big thank you. And if you are yet to subscribe to this YouTube channel, please do so you can enjoy the beauty of chemistry. Now, in today's class, we are going to be looking at the neco 2024 practicals, alternative A precisely. We have been given H2SO4, that is concentrated triiosocarbonate and sodium triiosocarbonate 4 as reagents to be used. We have been given the instruction that we should, in 150 centimeters cube of water, that we should dilute about 3.8 centimeters cube of concentrated tetraisosulfate 6 acid, and also label it as AN. Then for the B, which is the base aspect, we have been given sodium triiosocarbonate 4, and we have also been instructed that this should contain 6.00 grams per dm cube. All right. Having looked at that instruction, it's a very simple reaction. I mean, it's a very simple aspect, the quantitative analysis, because it's just an acid-base titration, a neutralization reaction, basically. So in that aspect, we have, I have basically selected a question which I feel we should look at it today, a sample question for the 2024 neco practical. neco 2024 sample question. A is a solution of hydrogen tetraisosulfate 6 containing 4.9 grams per dm cube. And B is a solution of sodium triiosocarbonate 4. Now the instruction says put A into the burette and titrate with 20.0 or 25.0 centimeters cube portions of B using methyl orange as an indicator. Tabulate your readings and calculate the average volume of acid used. Now B says, from your result and information provided, calculate the concentration of A in mole per dm cube. 2. Concentration of B in mole per dm cube. 3. Mass of the salt formed when 250 centimeters cube of B is completely neutralized by A. And 4. Volume of CO2 liberated in BII above. Alright. From my instruction, solution. Let's try to see how we can solve this very briefly. Solution 1. The first thing is put A into the burette. You know, you are going to set up your burette, your titration stand. Where you have your burette, you have your burette here, which numbers from you have from 0 to 50.00 centimeters cube. Assuming this is your burette, for example. Assuming this is your burette, for example. Assuming this is your burette. Okay, which numbers from 0, you have from 0 here to 50.00 centimeters cube. So what you do is, you take your A, which is your tetraiosocarbonate 6, then pour it into this your burette, which measures from 0 to 50. Make sure it's at 0 mark. At 0, make sure it's here at 0 mark. Then at this point, then if you start your titration, before you do this, you have to put out your titration table. Then you also pipette, then I say put A into the burette and titrate with 20 or 25 centimeters portion of B. Remember, the portion of B, you are going to also have your pipette. Let me also say that this is the introductory aspect, I mean the theoretical aspect. After now, we are also going to carry out the practicals, and we are going to drop the same practical, the practical on this channel. Then we will now pipette. If your pipette or if your center has 20.0 pipette capacity, use 20.0. If your center has 25.0 pipette capacity, use 25. So in my center here, what I will be using is 25.00 centimeters cube of pipette. So I will now pipette 25 centimeters cube of B, which is your sodium trioxocarbonate 4, and I will pour some into my what? My conical flask. My conical flask. I will pour some into my conical flask. I will pour some into my conical flask. I will pour some into my conical flask. Assuming this is my conical flask, my B will be here, while my A will be inside this burette, and here I will have my B being inside the conical flask. Then they also say that you should the 25 centimeters portion of B using methyl orange. Then I will now get my methyl orange. I will put maybe 2 to 3 drops inside my B, and I will swirl. I will shake it. I will shake it. When that is done, I can now bring my conical flask down here, and I start my titration. As I'm titrating, then it will get to a point that I will have. Remember that the color of the B here. Immediately I put my methyl orange here, I'm going to have a yellow coloration. I will have a yellow coloration. Then when this acid completely neutralizes this B, I will now have my endpoint here will now turn to what? Orange. My endpoint will turn to orange here. Alright, remember I said we are going to do the practical in the next phase. So this is the theory. Then assuming that we set up our titration table like this, we have our burette readings. Then under our burette readings we have final burette readings, we have initial burette readings. Then here we have one, or you can have your rough, your first, second, third. Then you have volume of acid used. Then all this will be in centimeters cube, Yes. Okay. Then, if my initial in the burette is 0.00, I do advise you to start from 0.00 if they have enough acid. 0.00, 0.00, 0.00. Start your initial from 0.00. Then, assuming I have 30.50 as my rough. The rough here is just telling me that when I was doing the titration, I was not that careful, like the name implies, the rough. I was doing it roughly, so I wasn't that very careful about it, so I was just doing it carelessly, and I eventually arrived at 80.50 as my final burette readings. Then the second one now, the rough has given me an indication that it will fall around 30.50. That means here now I have to be very careful. Then maybe when I did it, remember this is just an assumption. We have not done the practical. In the next phase or in the next video, we will be doing the practical. So these values might not correspond with the real values we will do. So here we can now have, assuming we have 20.50 as our first title value. Then the second one we now have maybe 20.60, and the third one we have 20.50. These values are close. This one is very far. These 1, 2, 3 are close. And like I used to advise my students, endeavor that your title values are between plus or minus 0.1, plus or minus 0.2. You shouldn't exceed that. So that at the end of the day, if you subtract this minus this, what you're having is 0.1. Then here this and here 0.1, and here this one minus this, we have 0.00. So here now, if the volume of acid used is gotten by subtracting the initial burette readings minus from the final burette reading. So you have 80.50, then 20.50, 20.60, 20.50. Calculate the average volume of acid used. The average volume of acid used is calculated using average volume of acid used is equals to first titer plus second titer plus third titer divided by 3. Let's take it up here. Divide by 3. Then here we have 20.50 plus 20.60 plus 20.50 divided by what? 3. We use our calculator. 20.5 plus 20.60 plus 20.5. We have, this is equals to 61.60. We divide it by 3. Divide by 3. We have, this is equals to 20.53 centimeters cube. Now, that is your V, your volume of what? Acid used. Now, from the first question says here, B, now from your result and information, this is our result and our information. Then from your result and information provided, calculate the concentration of A in mole per dm cube. So, I now, concentration of A in mole per dm cube. This will be equals to, from our, we have concentration in grams per dm cube is equals to concentration in mole per dm cube times molar So the first question, like I said earlier, is concentration of A in mole per dm cube. Then from concentration in grams per dm cube, this is equals to concentration in mole per dm cube times molar mass in grams per mole. Then we can now, since we are looking for this concentration of A in mole per dm cube, we can now make this the subject of our formula. That will now become concentration in mole per dm cube will be equals to this concentration in grams per dm cube of A divided by this concentration in grams per dm cube of A divided by molar mass of A in grams per mole. Now, that's the first thing we need to do. Then, having gotten this, we will now find what is our concentration in grams per dm cube. Concentration in grams per dm cube of A is equal to this. In the question, it is given A is solution of H2SO4 containing 4.9 grams per dm cube. So this is equal to 4.9 grams per dm cube. Now, molar mass of A. What is A? A is H2SO4. Then this will be equals to hydrogen is equals to what? Hydrogen is 1. 1 times 2 plus sulfur is 32. 32 times 1 plus oxygen is 16. 16 times 4. Alright, go for our calculator. This will be 2 plus 32 plus 16 times 4. This is 64. Then 2 plus this. We have this is equals to 98 grams per mole. This is our molar mass. This is our molar mass now, our molar mass in grams per mole. Then we can now impute these two values into this equation. If we do that, substituting we have that concentration in moles per dm cube of A will be equal to 4.9 grams per dm cube divided by 98 grams per mole. Then grams will cancel grams, right? Grams will cancel grams. Then 4.9 divided by 98. 4.9 divided by 98. We have 0.05, then 0, you can add 0 there, 0 moles per dm cube. Alright, so that is our Ca. That's our Ca now. Then I believe it is understood. Then II says concentration of B in moles per dm cube. Now concentration of B in moles per dm cube, since we have already gotten our concentration of A in moles per dm cube, we can now use cover CAVA all over CBVB is equals to N of A, number of moles of A, all over number of moles of what? B. Like I normally advise, make sure you write the equation of reaction here. H2SO4 plus your sodium trioxocarbonate 4. The equation of reaction should be the first thing you will write. Let's clean it so that we have space. H2II, H2SO4 plus Na2CO3. This will be equals to, we have Na2SO4 plus water. Yes, we have CO2 there plus water. This is gas, this is liquid, and this is in aqueous state. This is in aqueous state. This is in aqueous state. Now the number of moles of this A to B here is 1:1. Yes, so we can now use our cover CAVA all over CBVB is equals to number of moles of A all over number of moles of B. Now, when you are writing this equation, always remember to state the number of moles, the ratio of the number of moles of acid to what? The base. So you can say semicolon 1 over what? 1. Then our CA is equals to what? 0.05 moles per dm cube. Our VA is equals to what? From our table, we got our VA to be here 20.53. What's then our VB? Our VB is 25.00 centimeters cube. Yes. What again? Are we looking for the question? Then NA is equals to 1. NB is equals to what? 1. Yes, so this is what we are looking for now. So we can substitute this into this equation. If we do that, we have our CA is 0.050 times VA, which is 20.53, all over CB times 25.00 equals to 1 over 1. Alright? Yes. So let's take it up. Let's take it up here. Take it up. So if we do that, we now have 0 by cross multiplication. We have 0.050 times 20.53 times 1 equals to CB times 25.00 times 1. Yes. So if we make CB the subject of the formula now, that will now be 0.050 times 20.53 times 1 divided by 25.00 times what? 1. Alright, we do our addition and multiplication there. We have 1.0265 divided by 25.00, which is equals to 0, we have 0.04106. All right, so you can have, this is approximately 0.041 1 moles per dm3. So this is now your CB. All right, that is now your CB. Okay, so the next question, the next answer will be III. III says mass of the salt formed. Mass of the salt formed. Mass of the salt formed. Now here you can write the equation of reaction as well. H2SO4 plus Na2CO3. This will give you Na2SO4, that's sodium tetraosulfates, plus CO2 plus H2O. Now this is the salt form, okay? This is the salt form, and this salt that is formed is gotten, you can see from here. Alright? That's the salt formed now. An acid salt is what is formed there. So we are asked to calculate the mass of the salt that is what? Formed here. Mass of the salt formed. So the formula we are going to use is, mass of the salt formed will be equal to the molar mass of salt multiplied by the concentration of the base multiplied by the volume in dm3. All right. Now, what is the molar mass of this salt? Then we now find it. Na2SO4. Sodium is 23 times 2. That's the molar mass for sodium. Plus sulfur is 32. Plus oxygen, which is 16 times 4. Then you have there 23 times 2. That's 46. 46 plus 32 plus 64. We now add. That is, so this is equal to 142 grams per mole. So the molar mass of this salt now is 142 grams per mole multiplied by the concentration of the base. So 142 grams per mole is the molar mass of the salt that is formed. The concentration of our base, which is 0.0411, then multiplied by the volume in moles per dm3. Remember that here, that the volume in dm3 is the volume given is the mass of the salt when 250 centimeters cube of B is completely neutralized. So here, the volume is 250, so we'll have multiplied by 250 divided by what? 1000. Divided by 1000. So if we do that, we'll have 142 multiplied by 0.0411. We have 5.8362. That's what we have there if you multiply this by this. Then this divided by this. 250 divided by 1000. We have 0.25 multiplied by 0.25. Okay, so if you multiply this by this, the final answer you have the final answer to be 1.458 by my calculation, 1.458, which you can as well approximate to 1.46 grams. 1.46 grams. All right, 1.46 grams. Then we can now solve for the last question. The last question says volume of CO2 gas liberated in BII above. So from here, all right, volume of CO2 gas liberated, volume of CO2 gas liberated, volume of CO2 gas liberated. The formula we're going to use here is concentration of base. The formula is concentration of base multiplied by volume in dN cube multiplied by molar volume of the gas. Molar volume of the gas. Molar volume of the gas. So what's the concentration of the base? The concentration of the base is 0.0411 multiplied by what is our volume in dN cube? The volume in dN cube is 0.25. Remember, they said volume of CO2 gas liberated in III above. So you have 0.25 multiplied by the molar volume of the gas. Like it is stated here that 1 mole of the gas occupies 22.4 dN cube at STP. So we go back there. We put here 22.4 dN cube, which is our molar volume of the gas. So we now go into our calculation. So we now have 0.23016, approximately 0.230 dN cube. All right, 0.230 dN cube. Okay, now this is just a theoretical approach to NECO Practical 2024. This is not a true questions anyway, but this is just a revision towards the NECO Chemistry 2024 practicals. So in our next video, we are going to be carrying out the practicals too. Then we'll also look at other questions that is related. Please endeavor to follow up this channel. Then also in our next video, we will be looking at the qualitative aspect, the SWOT analysis. In the SWOT analysis, let me briefly tell you this. In the SWOT analysis, what is expected of us is that we are asked to make provision for powdered milk solution, and also we are also asked to make provision for zinc chloride. Zinc chloride is a very simple one anyway. The Cn is our zinc chloride, and the Dn is our solution of a powdered milk. So we are expected to work on zinc. And we are also expected to work on powdered milk. On seeing powdered milk, you know that is test for proteins using burette tests. And also in zinc chloride, we'll be testing for zinc ions only in the presence of sodium hydroxide and using ammonia respectively. Thank you very much for watching us. We look forward to seeing you in our next video. Please do like, share, comment and subscribe. God bless you.